Namaskar, welcome to Exercise Explained. In this video, I would be doing question number 9, 10, and 11 of exercise 4A, ICSE 9th, Pressure in Fluids and Atmospheric Pressure. The previous sums have been done in separate videos, the link for which are there in the description below. Do check them out if you have not checked them still, and consider subscribing to the channel and do share it with your friends. Starting with the ninth question, what should be the ratio of area of cross section of master cylinder and wheel cylinder? Now, to explain this, I can explain it in very simple terms. In a car, when the driver applies the brakes, the pressure from the brake pedal is taken to a master cylinder, and from the master cylinder it individually goes to all the four wheels, which will have separate brake cylinders. So I hope you understood what is the job of a master cylinder and the job of a wheel cylinder of a hydraulic brake, so that force of 15 newton can be obtained at each of its brake shoe by exerting a force of zero point 0.5 newton on the pedal. So the driver needs to exert a force of zero point 0.5 newton, and that should multiply to 15 newtons. So we need to find the ratio of area of cross section. So if you have seen the previous video, we will be using this formula here. So I can write area of master cylinder divided by area of wheel cylinder is equal to force on the pedal divided by force on the brake. Now force on the brake is 15 newton, that is required, and force on the pedal is 0 0.5 newton, that is given in the question. This comes from the equal pressure on both sides. That means pressure on brake should be equal to pressure on wheel. So equation 1, that is this equation, becomes area of master cylinder divided by area of wheel cylinder is equal to force on the pedal happens to be 0 0.5 divided by force on the brake, which is given as 15 newtons. So I multiply numerator and denominator by 10. So I get it as 5 divided by 150, which is 1 by 30. So the ratio of area of master cylinder to the area of wheel cylinder should be equal to 1 is to 30. So that was a easy question. The ninth question was pretty easy, simple. Getting into the 10th question of exercise 4A, ICSE 9th physics. The areas of pistons of a hydraulic machine are 5 centimeter square and 625 centimeter square. So definitely the smaller piston is 5 centimeter square and the bigger piston is 625 centimeter square. What force on the smaller piston will support a load of 1250 Newton on the larger piston? State any assumption made. So on the larger piston we should have 1250 Newton of force. So the assumption here is pressure on smaller piston is equal to pressure on larger piston, as we have been doing in question number 9 and question number 8. So similar thing, F1 divided by A1, that happens to be for similar smaller piston, and F2 divided by A2, that happens to be for the larger piston. So the force on the smaller piston we need to find out. So F1 we need to find out. A1 is given as 5 centimeter square. Now 5 centimeter square, when we convert to meter square, we multiply by 10 to the power of minus 4. Remember, whenever we are converting centimeter square to meter square, we multiply by 10 to the power of minus 4. If you have any confusion regarding conversion from centimeter square to meter square or from millimeter square to meter square, do check out the first video of this exercise, that is the video in which I solved question number 1 and question number 2. In that particular video, I have explained it step by step how to convert centimeter square to meter square or how to convert millimeter square to meter square. Coming back to this, F2 is 1250 newtons, that is force on the larger piston, divided by A2 is given as 625 centimeter square, which again happens to be 625 into 10 to the power of minus 4. So now I take this 5 into 10 to the power of minus 4 to the other side, and I get F1 is equal to, before that I cancel 1250 divided by 625, that happens to be straight away 2 times. So we get 2 into 5 into 10 to the power of minus 4. This 5 into 10 to the power of minus 4 came from the left hand side. Divided by, we have 10 to the power of minus 4 in the denominator. 10 to the power of minus 4, 10 to the power of minus 4 cancels, and we get 2 into 5, that is equal to 10 newtons. So we need to apply a force of 10 newton to support a load of 1250 newton on the larger piston. Assumption: no friction, no energy loss, no leakage. This is the assumption for all problems of this chapter. So in case you get any problem in which assumption is asked, you can write the same reasons. Coming to the last question for this particular video, that happens to be the 11th question of exercise 4A ICSE 9th physics. The diameter of neck and bottom of a bottle are 2 centimeter and 10 centimeter respectively. So the diameter of neck definitely will be smaller than the diameter of the bottom. So the diameter of neck is 2 centimeter and the diameter of bottom is 10 centimeter respectively. The bottle is completely filled with oil. If the cork in the neck is pressed with a force of 1.2 kgf, now it is given in kilogram force, what force is exerted on the bottom of the bottle? So similar question, very similar, but before that we have the diameter, so we need to relate the areas. So I have to find the radius. So I can write radius of the neck. So diameter was 2 centimeters, so 2 divided by 2. So the radius happens to be half of 2, that is 1 centimeter. Now 1 centimeter, when I convert it to meter, it happens to be 1 into 10 to the power of minus 2 meter. Radius of the bottom happens to be 10 divided by 2, that is 5 centimeter. Now when I convert centimeter to meter, again I multiply by 10 to the power of minus 2, and I get it as 5 into 10 to the power of minus 2 meter. Force on neck is equal to 1.2 kgf. Now 1 kgf is 10 newtons, so 1.2 kgf will be 12 newtons. So now our general assumption which we are doing from last 4 problems, that is pressure on the neck will be equal to pressure on bottom. So now we can write force on neck divided by area of neck is equal to force on bottom divided by area of bottom. So force on neck is given as 1.2 kgf, which happens to be 12 newtons, so I write it as 12, divided by area of neck. Since it is circular, area formula is pi r square, and r we have got it as 1 into 10 to the power of minus 2. So pi r square happens to be pi into 1 into 10 to the power of minus 2 the whole square, is equal to force on bottom we don't know, so I took it as F, divided by area of bottom, again pi r square, but r is 5 into 10 to the power of minus 2, so pi into 5 into 10 to the power of minus 2 the whole square. Now we can cancel pi and pi here since we have pi on both sides. 5 into 10 to the power of minus 2 goes to the other side. Now 5 square is 25, that is how I get this 25. 10 to the power of minus 2 square is 10 to the power of minus 4. And here in the denominator 1 square is 1, so I have considered not writing it. And 10 to the power of minus 2 square is 10 to the power of minus 4, so I have written this 10 to the power of minus 4. We have 10 to the power of minus 4 in the numerator as well as denominator, so both of them cancel. So we have F is equal to 12 into 25. 12 into 25 gives us 300 Newton. Now you can definitely leave your answer here, but the textbook answer was given in kgf, that is kilogram force. So I converted it to kgf and we get it as 30 kgf. So 30 kgf is the force on the bottom of the bottle. The question also has a B part. So the B part of the question says, name the law principle you have used to find the force in part A. So it is a definite answer. It is Pascal's law. So we have used Pascal's law from past 4 or 5 problems. I hope you guys would like the video. Do share it with your friends and consider subscribing to the channel. Next question one onwards will be there in the next video, the link for which I would put up in the description below. So see you guys in the next video. Dhanyavad.